Hello everyone, this is Nitya Priya, and here also in this operating system class we see the concept of IO programming. This is how the content of the presentation has been arranged. IO programming first, we see the types of IO channels next, then we see the IO programming concepts, then we see the communication between CPU and the IO channels. Right, first we see IO programming. What is IO programming? IO is input and output that you know. IO programming is, before getting into IO programming, let us see the computers in early days. In early days, in computers, we had only memory, the IO devices, and the CPU, which is known as processor. Right? Only three things we had in early days computers. So, what about operating system? We didn't have any operating system for the early day computers. We had only these three things: memory, IO devices, and the processor, which is CPU. Right? So, the computer's performance was determined by, as you see here, CPU speed and the memory size. Right, there is one more specialized processor which is called IO processor. And what is IO processor? IO processor is something that handles the IO devices. We can also say IO processors as IO channels, because IO channels or the IO processors only see out the transfer of information between the main memory and the IO devices. Okay, so they channelize the data movement between these two things, memory and the IO devices. So these are called as IO processors or IO channels, right? Then telling about this IO channels, each and every IO channel will handle each or every single IO device. For example, if there is one card reader, there will be one IO channel for handling this card reader. So that is like how many IO devices we have, that many IO channels we should have. Okay, so that is one thing about IO channel. And one more thing is IO channels, because each and every IO channel will handle only one IO device. We can have many IO channels if we have many number of IO devices, right? Then the IO processors are simple, they are specialized, and they are less expensive than the processor, which is CPU, right? So they are simple processors which handle only the IO device data transformation between memory and the IO device, right? So we are going to implement this IO channel or the IO processor within the computer, and this is the system which has the IO channels, right? See, the memory is in the middle portion. Above there is CPU, and there are some 4 IO channels: IO channel 1, IO channel 2, 3 and 4. We can see here each and every IO channel is connected with one IO device, and all the IO channels are controlled by the processor, which is CPU. The dotted line says the control lines, and other solid lines are just data lines, right? So this is how the system is connected in early days, right? Now we see the types of IO channels, because now we are concentrating on IO programming, and here we see the types of IO channels, right? Now why these types of IO channels have emerged, we have to see that. Why do we have types in IO channels? See, IO channels differ in size, shape and complexity, right? Even though IO channels are cheaper, we have to connect every IO channel with only one device. So this has led to us to have many IO channels connected in a single computer. So to avoid this, what we have is, we have special types of IO channels like selectors, multiplexers, block multiplexers, etc. Right? So because of that reason, we have the types of IO channels: selectors and multiplexers. Now we see selector first. What is a selector? A selector is a channel which can serve only one IO device at one time. Right? It cannot serve two or more devices simultaneously. It can serve only one IO device at a time. So this is called selector. We will see the diagram of selector later, then we will better understand that. So because the selector can handle only one IO channel, we ought to have high speed channels, high speed IO devices for the selectors, such as magnetic tapes, drums, discs, etc. Right. The next type of IO channel is multiplexer. What is multiplexer? Multiplexer, irrespective of the selector, the multiplexer can simultaneously serve multiple devices. Selector will serve only one device at a time, but multiplexer can serve more than one devices or multiple devices simultaneously. So this is called multiplexer. Because multiplexer can serve more multiple devices at a time, we can have slow IO devices for multiplexers, such as card readers, card punchers, printers, and the other things we can have using multiplexers, right? And the third type of IO channel is block multiplexer. Now, a block multiplexer is a channel which can serve multiple high-speed devices to be active in the same IO channel. So this is the biggest option at block multiplexer, right? So it performs one channel instruction for one device and automatically switches to perform the instruction for another device. So this is how the block multiplexer will operate. Here we see the overall system which has all. It has selectors, it has multiplexers, and it has block multiplexers too. Above we have processor which is connected to memory. Then we have multiplexer channel. In the middle we have selector. Selector is handling only one device at a time. See? And on the left side we have multiplexer. Multiplexer handles more than one devices at a time. Right? And see the block multiplexer. Block multiplexer handles more than one device, that too high speed devices. So that is called block multiplexer. Right? So everything is controlled by the processor using control lines. You can see here the dotted lines are control lines. So this is the system with multiplexer, selector and block multiplexers. So now we see IO programming concepts. We saw what IO programming is. Then we saw what IO processor or what IO channels are. Then we saw the types of IO channels, and here we see IO programming concept, right? So the operating system in a computer plays the role of a ringmaster to control the other processes, right? So operating system is all that manages every resource in a computer system. For this sake, to do this, OS will handle certain programming concepts to handle the entire thing successfully. So this concept is called as IO programming concept, right? So what is IO programming concept? There is a communication between processor CPU and the IO processor, right? So when CPU talks to IO processor, in other words, when CPU communicates with IO processors, they do it with IO instructions. Then when the IO processors connect with the CPU, they do it with interrupts. So this is the difference. CPU communicates with IO instructions, and IO devices or IO processors communicate with CPU with interrupts. So this is about the communication between these two, right? The IO channel instructions or IO programs, they depend upon memory of the computer, the registers that it has, data, the amount of data that is being transferred, and the instructions or the types of instructions being used. So the IO channel instructions or IO programs depend upon all these things. Right. These are the IO instruction types. There are data transfer instructions, device control instruction, and branching instructions, right? So when an IO channel is handled, it's being handled using something called CCW, which is called channel command word, and this is the format of channel command word. On the first field it is opcode, next to it we have data address, next to it we have flags, then we have count and some portions in the middle which is unused, right? So this is the format of a channel command word which is used mainly for IO programming, right? Now we see the fields of this CCW in detail. First is opcode. What is opcode? Opcode is the command to be performed. For example, when we say move A comma B, the move is called as opcode. Or we can say load X comma Y. This load is called as the opcode. So the command that is to be performed is specified in opcode field. The next one is data address. So data address is the address in which the data resides. That is data address. That says the beginning of the address of the data, right? Then flags, right? So there are from 32 to 36 there are flags. So we see from 32 to 36 what are about the flags, we see that. So in bit number 32 we have data chain flag. What is data chain flag? The storage area indicated in the next CCW is to be used in the current command. If that is the case, the data chain flag will be set, right? Then command chain flag, right? The next sequential CCW is to be executed in the normal completion of the current command. The normal only after the normal completion of the current command, the next CCW can be executed. If in that case, the command chain flag will be set. The next flag is suppress length indication flag, which is on the bit number 34. So this is the indication of the program of incorrect length. So no need to explain further. Then skip flag. Skip is transfer of information, a particular information. Transfer of a particular information is suppressed to storage. If that in that case, if that is the case, the skip flag will be set, right? In the next flag we have, next bit we have program control interrupt flag, which causes the channel to generate an interrupt condition. Okay, if there is an interrupt arises, this flag will be set, right? So that is all about the flags and the CCW, right? Now we see the communication between CPU and the channels, right? So CPU and IO channels, the communication between these two we are going to see. There are two types of communications. One is CPU to the IO channels. The next type is IO channels to CPU. So I already said CPU, when CPU connects to the IO channels, this will be done with the help of IO instructions. When channels or IO channels communicate with CPU, that will be done with the help of interrupts. Interrupts we see later in the next video. We see only the first type, which is CPU to channel communication, right? So CPU to channel communication, for this thing we have IO instructions, right? So and the IO instructions will be having this format, right? It is of 32 bits. The first 8 bit we have opcode, then we have channel number in B1, and we have the device number which is stated as D1, right? So there are 3 types of IO instructions, namely start IO, halt IO and test IO. Start IO is the start IO is, it has the channel number and the device number. The start IO specifies the start of the IO channel. Then halt IO. Halt IO is the execution of the current IO operation when it is abruptly terminated. That means it is halt IO, right? Halt. It is halted. That means. Then we have test IO. Test IO is when CPU indicates the status of the current address channel by the condition code, which is CC, right? So the current status of the address channel is specified by CPU by this IO instruction called test IO, right? So here in this presentation we saw the entire thing about IO programming. We saw what IO programming is, then we saw the types of IO channels, then we saw the IO programming concepts, and the all other things we saw. Hope you understand the IO programming concept. I'll see you in the interrupts with the concept of interrupts in the next video. Thanks for watching.